Welcome to what will hopefully prove to be a very interesting and stimulating discussion of the role of physical and mathematical principles in brain structure, sponsored by the NSF and the Kavli Foundation. And my name's Herbert Levine from Rice University. I'm sort of acting as an impartial organizer to try to get everything moving and have fruitful discussions. And we'll first hear from Denise Caldwell. Denise is the newly appointed director of the physics division at the National Science Foundation. She's had a major role over the last number of years in furthering physics of biological systems as a vital and important area for physics research. And without that, I'll just give you Denise.
Thank you, Herbie. And I'd like to welcome everyone to this workshop. Looking out over the room and looking over the list of the attendees and the input that we've had thus far, I think this is going to be a very interesting and exciting meeting. I would hope that by the end of 2 days, well, over the course of 2 days, to hear a lot of discussion about a lot of very interesting and exciting science. And I would hope that by the end of these 2 days, that what could emerge is the identification of and I will say very few, sort of overarching questions, areas, however you term them, that will serve to guide the necessary focus over the next few years, where additional intellectual endeavor, and might once also say investment, could drive some major breakthroughs. So we're really looking forward to that. Herbie had already mentioned the fact that the physics division for, I would say, the past 5, 6, let's say decade, has increasingly focused on the physics of biological systems or the physics of the living world as one of our primary areas of research. We established what is now the Physics of Living Systems program, and we saw at 2 physics frontier centers in biological systems emerge out of some very, very brutal competitions. What we do is what I consider as part of the physical life sciences interface that one has heard talk about a lot over the past few years. And what has really driven this interface has begun, I would say, as it so often does, with the ability to make ever finer measurements of within biological systems, which we all know are very, very complex. But measurements at a level of detail that have been fostered by the new experimental tools that we have, from optical and X-ray imaging, microfluidics, gene sequencing. Well, you know them probably better than I do. We've learned a lot more. But I think one of the major areas of impact has been the increasing role of theory. Theory in the broad analytical sense, where theorists look at the data that's available, they attempt to extract from that data concepts, overriding principles. Do they exist? And if they exist, what are they? And using what we've learned from this theoretical thinking to then suggest new experiments that will either reinforce or completely negate what we've been thinking about. This is, if you wish, it's an approach that has been very successful in the physical sciences, and I think that we are getting to the point where we can see this approach being more and more effective in the biological sciences. I would have to say that I really think that major advances at the physical life sciences interface, whether it be in neuroscience or molecular biophysics, whatever it is, really has to be done in partnership. You can't have just physicists working alone, just as you really can't have biologists working alone, but you have to have a partnership between the 2 disciplines. And the physics division has been very fortunate that over the past, over the past decade, we've established a very close working relationship with the Biosciences Directorate, and in particular, the Division of Molecular and Cellular Biosciences. We have numerous co-funded awards, and in particular, a real partnership in the co-funding of the two Physics Frontier Centers, one of whom you will become closely acquainted with at Rice University, who's helping organize this workshop. However, I would say that the physical life sciences interface is not just restricted to physics. Even though the physics division, together with the Kavli Foundation, initiated this workshop and started the initial planning, the physical life sciences interface crosses not just physics, but multiple areas within the Mathematical and Physical Sciences Directorate, some of which actually have a closer working relationship with the biology community than physics has developed over the past few years. And by that I mean chemistry, mathematics, material science. And to speak and to give you this very broad perspective in which the physics and these divisions within the mathematical and physical sciences are bringing to this physical life sciences interface, I'd like to welcome Dr. Fleming Crimm. Dr. Crimm is the Assistant Director for Mathematical and Physical Sciences. He is a physical chemist on leave from the University of Wisconsin to join us. We are very welcoming to him. We're glad to have him in MPS and at NSF. And I'm going to ask him welcome him to give us his perspective on what we're here about for the workshop. So Dr. Crimm, welcome him to give us his perspective on what we're here about for the workshop. So Dr. Crimm.
Thank you, Denise. I am Fleming Crimm. I am one of the assistant directors of the foundation. I oversee mathematical and physical sciences, and I had an interesting conversation over tea with one of the participants in this meeting, who asked me to please not talk too much. She was extremely polite about it, but she asked me not to talk too long. So I want to thank a few people and make a. I won't identify you, but all your colleagues can thank you, okay? I do want to take just a few minutes to thank some people and to set the stage for some of the things we're going to be doing today. Mathematical and Physical Sciences, the Mathematical and Physical Sciences Directorate at the National Science Foundation consists of astronomy, the divisions for astronomy, chemistry, physics, materials research, and mathematics. Denise named 4 of those divisions as being important players in our interface between the life sciences and the physical sciences. I'm a physical chemist, as Denise said, with this very molecular view of the world. And it's been interesting coming to MPS because I've been learning about big telescopes and lots of other things that I didn't know about. And in thinking about and looking at the white papers for this meeting, I've been learning about a lot of neurological function and sort of mesoscale sorts of things that I don't think about much as a physical chemist. So it's a very exciting endeavor. This is the heart and soul of what many of you do, but to me it's really interesting to be seeing this. NSF has a special role to play, we think, in this BRAIN initiative. A role that we can play in partnership, particularly with NIH and with the other agencies involved and the foundations involved. I want to thank a few people, as I said, to start with. I want to thank all of you for participating. The purpose here is to generate ideas and identify opportunities, and having this group of people, a group of people who are thinking about all these aspects of the problems at hand is really an important aspect of it. I particularly want to thank the organizers, Winifred Dink, Herbert Levine, Partha Mitra, Aravi Samuel, Terry Shanowski, and Van Whedon. I'm sorry, Terry. I particularly want to thank the organizer, Sarah Bradley, who's done a lot to pull the details together. I need to thank my colleague, John Wingfield, who is the assistant director who oversees the biology directorate. As Denise said, there are a lot of connections between our directorates, and also each of us have connections to different communities. And so we have a connection with NSF that is bringing two different communities together, and a connection outward to communities that we think is extremely useful. 3 people from NSF, Krastan Blagoev, James Deschler, and Diane Witt are the people who really made this happen at the detailed level. Krastan is from the Mathematical and Physical Sciences Directorate, from the Physics Division. James and Diane are from the Biology Directorate. Another example of this connection that we have already built. So this idea of understanding brain function from the cellular level or the molecular level to the systems level is really daunting. It's also is an extraordinary intellectual opportunity. At NSF, we think that there is a role to connect basic science to some of the outcomes that one wants to have eventually in therapies or something. But at NSF, we are looking toward meeting the challenges of some of the fundamental science associated with these kind of problems. It was really interesting to glance at the white papers that folks have generated. There are a lot of really interesting and challenging ideas there. Clearly, many of you believe that we need the techniques for making measurements. A variety of different techniques. We need dynamic techniques that can follow things in time. Clearly, many of you say that data are a critical aspect. Mining data, dealing with a little bit of sparse information in a big data set, that sort of thing. But in addition, when you look at these white papers, you see that folks are saying we need theoretical models. Not just conceptual models, but detailed mathematical models. Now, there are efforts already to build all of those things, and I believe this initiative and the ideas that are going to come out of this workshop are going to propel those sorts of things along. So, we think connecting the life sciences, the physical sciences, and something that's important to us at NSF, engineering, is a way to make progress on these areas. So in fact, we see in the long term not only the Biology Directorate and the Mathematical and Physical Sciences Directorate, but the Engineering Directorate being involved. For example, in our Biomaps initiative, Biology, Mathematical, and Physical Sciences, engineering, they don't get a letter in it, but they're a big player in it. We just didn't know how to pronounce it if we put an E in it. Biomaps, I'm not quite sure. So, the chemists, the physicists, the material scientists, the mathematicians, all are eager to seize the intellectual opportunities that this offers. I'm not going, I have a little list of some of the things people have accomplished. I'm not going to, I'm going to do something for you. I'm not going to go through that list because you know that list better than I do. If we succeed, even if we partially succeed in some of the ideas that you're talking about here, we're going to generate a profound understanding of an enormously complex system. I see not only the Biology Directorate, the Mathematical and Physical Sciences Directorate, the Engineering Directorate involved in really working this problem, but our computer scientists are going to be involved, and the social and behavioral scientists are going to be involved. This is really a grand challenge to understand the brain at the level that this initiative calls for. And this group, looking at the mathematical and physical problems, I think is sitting at a critical spot to do that. So you can imagine that we're going to that this sort of work leads us to understand healthy brains and diseased brains and treating disease and repairing damaged brains and restoring function. It's a pretty exciting prospect, even for a physical chemist, okay, who's looking at this in some direction. As those of you who have written about this, and many of the people who've formulated these problems know, this is a long-term endeavor. There are going to be simple systems, model systems, and eventually moving to these more complicated systems. I believe there are enormous intellectual opportunities here. And we at NSF want to define those opportunities, and one of the things I hope will come out of this workshop is some of that definition. What we're asking you to do is help us define the directions that we should go in, the things that we should be stimulating and funding in order to make progress on this daunting and important problem. So I'm looking forward to the part of the workshop I'm going to get to hear. I'm also very much looking forward to seeing the results of the workshop. I want to introduce Mi-Young Chun from the Kavli Foundation. She is the research director for the Kavli Foundation and has been closely involved in initiating this whole process, and I think is probably even more interested in the workshop than I am. So, Mi-Young?
Thank you very much, and welcome. It's really actually wonderful to see all of you sitting here. In the next 15 minutes, I would like to describe some of the key events that the Kavli Foundation coordinated in initiating and developing what would become the BRAIN Initiative. Over the last 20 months, many people from various organizations were involved in this project. I think over 100 scientists, many members from OSTP, NIH, NSF, DARPA, HHMI, Allen Institute for Brain Science, and others were involved. But today, I'll describe the activities what I was involved with, working closely with scientists, only because actually I don't know the details of what other people were doing. So I noticed that majority of people who were working on this project for the past 20 months are all here today. So I would love to hear your stories during next 2 days or so. Okay, so if we can begin. I think I know. Okay, there we go. From my perspective, everything began with sort of the kind of philosophy that we have at the Kavli Foundation. Going from great ideas to, I think, eureka moment in scientific discovery takes unbelievable amount of, I think, innovative thinking and tenacious research activities among scientists. But it also takes large resources. And the biggest resource comes, of course, from federal agencies. And when it comes to supporting, I'm sorry, but there's actually this noise, if you can help. So I have to now multitask, okay, multiple things here. Okay. So, but when it comes to supporting basic science, the funding discrepancy between amount that federal funding has compared to private funding, all combined, is actually huge. So one may ask, what can a very young and small foundation like Kavli Foundation do to make any difference in advancing science? And so we had to be very strategic, and we really looked into what our advantages do we have. And we like to think that one thing that we do well is we can make decisions really fast. If I have a great ideas, I can just go to my president's office, which is right next door to me. And very often, before my sentence is over, he will say, "That sounds great, go and try and tell me if it works." And importantly, if I tried and if things doesn't seem to work out, and we make decisions either changing our minds or stopping doing some things that we initiated as fast as we made decision in the first place. So I think it's the agility and flexibility of decision making is really empowering us. So I would like to think that there's some play among the foundations in making sure that great idea actually goes to the scientific discovery. And so in practical sense, I put together a lot of workshops and really hoping to generate lots of good ideas. And then I find my opportunities along the way of this process. So then I either put together more workshops to deepen scientists' thoughts or finding a roadmap for any initiatives that we have in mind, and so that we ensure that this process moves forward. In addition to these horizontal activities, I would like to think that we can also have these vertical activities of making sure that the foundations can actually play a role in facilitating interactions between scientists and funding agencies, not only public but also private funding agencies. And I think that it will be very important for us to remember that we should always include industry early on in these discussions. And so what does this philosophy mean for the BRAIN initiative? I would like to think that I followed this philosophy all the way as I was aiding in developing the BRAIN initiative. I have to confess, I think that I must have had over 1,000 phone calls and teleconferences and 100 meetings and such during September 2011, which was the very first workshop that I put together in collaboration with other foundations, and the president's announcement in April this year. But looking back on it, there had been about, I think, 12 key events that had occurred. And those events can be divided into, I think, 3 activities. First activities are scientific workshops, as I mentioned from the very first meeting. And then the foundation put together 4 more workshops, one in January 2012, December 2012, and 2 meetings in January 2013. These workshops led to a variety of different write-ups that, as many of you have seen, there were white papers that was written right after our September 2011 meeting. And then NeuroView article was written after first workshop in January 2012, and then other papers were written in later stages. And in effect, after my talk, we have this folder that includes all the write-ups that we've been doing between those white papers as well as other articles that's been written. So I hope that you can take a look at them. Other category of meetings that we had, and numerous of them, but I think that there were key 5 meetings that was relating to interagency brainstorming meetings. Namely, one I think was in December 2011, and then there were several between March 2012 and then October 12th. And these meetings then led to the President's comment on State of the Union address and his official announcement in April 2013. What I thought I will do next few minutes is just describe some of the details of these events. So in our minds, it all began in September 2011. Allen Institute for Brain Sciences, Gatsby Charitable Foundations, and the Kavli Foundations put together a workshop called Opportunities at the Interface of Neuroscience and Nanoscience. And I think that we all agree that next great scientific discoveries could come from interdisciplinary research and from the Kavli Foundation's perspective, because we do support nanoscience and neuroscience, we really wanted to see what those scientists can get together and come up with great ideas. Here today, there are lots of members who are here today are the participants of this meeting. It was held at the Chitley Hall. It's the home of Kavli Royal Society International Center. It's about 30 minutes north of London in Buckinghamshire. It's a beautiful country estate of about 80 acres, and it has about 50 bedrooms, and then it's a conference center that can hold about 150 to 200 people. And any of you actually would love to go there and have meeting, please propose a meeting for me, and I can host it. And from this meeting, at the very last 2 hours, we were really talking a lot about blue sky ideas about what can be a possible collaboration between nanoscience and neuroscience. And I think the neuroscientists specified that despite great effort invested in understanding, I think, neural circuits and so on, we still do not have a general theory of how brain really works. And one of the key bottlenecks that was discussed at that meeting was the technology development. So at the end of this meeting, 5 scientists, Rafa Yuste, Ralph Greenspan, 2 neuroscientists, and 2 nanoscientists, Michael Rukas and Paul Alivisatos, and George Church, 5 of them actually got together and wrote this first white paper, which we sent it to OSTP in a month, which is by October, we sent this white paper to them. And here, actually, they describe the ultimate goal they envisioned at the time as to construct the functional connector map of the human brain by assembling a coordinated network of researchers deploying next generation nanotechnological tools with unprecedented capabilities. We've actually written many more white papers since this white paper. Namely, in few days later, Michael Rukas led, and then these 5 scientists actually wrote together, defining what could be the possible technological foundations of this project. And as I mentioned again, I put together all these 2 white papers, but also other white papers that we have written in ensuing months. When we sent these documents to OSTP, they thought that this was actually a very grand idea and very good. And they actually told us that they circulated these documents to NIH and other funding agencies. And we knew very quickly that if this project would be initiated, NIH, of course, will play a very important role. So I started to make a concerted effort getting in touch with Story Landis, who's the director of NINDS. And finally, I caught up with her in November at the SFN annual meeting. And I remember one thing that Story mentioned that encouraged me to think a lot about this project, and that is, she thought that if this project would be initiated and be successful, that it will answer a lot of holy grail questions in neuroscience. And then she and I decided that perhaps maybe the scientists could come to NIH and then talk about this project a little more. So by December Michael Rukas, George Church, and Rafa Yuste actually went to NIH, and Story put together a wonderful group of, I think, almost 20 members from NIH. Tom Insel was there, director of NIBIB, and other directors and deputy directors and program directors were there. This is actually a scene from the hotel where I think Rafa and Michael were working literally all night generating these first sets of slide presentations, and this meeting actually was encouraging for us because that they were really thinking that maybe we should think a little deeper about this project. So then quickly, 5 of them and then myself organized a workshop in January 2012 called Toward the Brain Activity Map. Again, many of you who are, I saw Eve here, and did I see Sebastian? Many of you are here today from that meeting. I made sure that I hosted the meeting at this beautiful hotel right at the beach in Santa Monica, right next to the pier. So then a lot of East Coasters actually were happy to come and join us in the middle of January. And as you can see, it was a beautiful day in LA. The outcome of this meeting, I think, is the paper that many of you may have been aware now, is the neuronautical called NeuroView. The title of that paper was The Brain Activity Map Project and the Challenge of Functional Connectomics. And here then we proposed of the launching of a large-scale international public effort. By this time then we call this project the Brain Activity Map, aimed at reconstructing the full record of neural activity across complete neural circuits. The corresponding author for this paper is Rafa, because he's the one who wrote first drafts of most of, I think, all the write-ups that we have in following times. And I would like to actually emphasize that this was our first set of thinking. Ever since then, we've had actually many other write-ups, which then evolved our thoughts quite differently. There were multiple interagency meetings between March 2012 and October 2012. By this time, we included a lot of different groups of folks. The core group of scientists group had been also enlarged, such that by that time, Carl Roth, John Donahue, Terry Sonosky, and more actually physicists and chemists also joined, Paul Weiss, Paul McEwen, Hong Kong Park, and so on. Here is one of the examples of the meeting. In this case, it was in August, hosted by Tom Khalil here and Phil Rubin at OSTP. And they brought together folks from NIH. Tom Insel was there from NSF, Diane Witt was there, DARPA, Jeff Ling was there, and I brought together lots of folks among the scientists as well as representatives of different private funding agencies. Nelson Spruceton from HHMI, Alan Jones from Allen Institute, and then other representatives from Gatsby, Wellcome Trust, Simons, and so on. These meetings actually encouraged us to then put together more workshops, defining further, understanding what are the current technology status for brain activity measurements, as well as what could be the future technology advancement could be, which was the workshop that we put together in December 2012 here in Arlington. And I also want to make sure that many of you who are here really put a lot of effort in defining these ideas. We had another meeting, in this case a little more local, organized by John Nye at Berkeley, but it was more of the Bay Area meeting, incorporating folks from UCSF and Stanford. These meetings then led to 2 consecutive papers that came out in March 2012, one of which is a perspective paper in Science, defining at this point the BAM project is essentially a technology building research program with 3 goals. One is to build new classes of tools that can simultaneously image or record the individual activity of most or even all neurons in brain circuit. And second is to create tools, and third is to understand circuit function. Another paper was published in ACS Nano, defining nano tools for neuroscience and brain activity mapping. Terry Sonosky was actually quite concerned about data deluge that will come out of this project, and he hosted a meeting at Caltech in January 2013 titled Data Deluge for BAM. Again, many members of, I think, that meeting are here today. And Terry wrote, I think, really, Terry and the participants wrote, I think, very thoughtful report on that meeting, which I also have it in this packet, so I'll put it out at the end of this talk. All these activities actually led to something, but something that was a bit surprising. I was actually just watching State of the Union along with my daughter, and it began around 8 o'clock in Californian time. And around 8:10, Preston mentions something like, today our scientists are mapping the human brain and so on. And I remember that my daughter, who knew that I was working on this project for a long time, she stood up and said, "Did he just mention your project?" So I wasn't sure about that either. But then by 8:15, actually, I had an email from Tom Khalil saying that congratulations, you just made the State of the Union address. So I think it was a really pleasant surprise. And I think that that night, Francis Collins tweeted mentioning Obama mentions the NIH brain activity map. And these, I think, events led John Markoff, New York Times writer, to actually leak the story about perhaps Obama administration is going to have a big study on human brain. And that led to, I think, April 2nd Brain Initiative announcement by President. I think many of you were there and witnessed the kinds of things that President mentioned. Some of us actually had chance to meet with President right before the announcement. I think generally head of different kinds of funding agencies. But I'd like to really emphasize the thank you in initiating and developing this, the Brain Initiative goes to, I think, original 5 scientists. This was a high-risk activity that, none of us thought that it would happen. And therefore, their, I think, volunteer activities is just heroic to me. And so let me just name them again. Rafa Yuste, who must have actually attended every meeting that I organized, and Ralph Greenspan, George Church, Michael Wilkes, and Paula Livisatos. And as I mentioned that there were core scientists, I think that by having John Donahue, we all of a sudden humanized our program by now then studying perhaps a human study. Carl Dijsselrath had made unbelievable contribution from the beginning September 2011 meeting. Terry Sonosky, always a leader, and he must have made more likely 1,000 phone calls between February and April spanning time. And Paul Weiss, Hong Kong Park, and Paul McEwen are our great nanoscientists who led a lot of activities. In particular, I'd like to thank Paul Weiss for having ACS Nano paper as it came out, which is really unbelievable. I think that greatest thanks goes to Tom Khalil, who has led all these activities, I think, so wonderfully, and Phil Rubin from OSTP, 2 of them. And I cannot thank enough for really gentle guidance and enthusiasm that Story Landis and Tom Insel provided. They are, I think, the true leaders, and I really appreciate them. So I'd like to end my talk by just having one sentence from President Obama. And so let's see if I can, oops.
Let me do it.
Okay.
So I'm very excited about this project. Let's get to work. God bless you, and God bless the United States of America. Thank you.
Okay. Thank you very much.